We at Yonder Dynamics are excited to present Latency, our rover for URC 2024. Through thorough testing and iteration, Latency systems have proven to be robust in core functionalities across all 4 missions.
To perform delivery tasks, our drivetrain utilizes a rocker bogie suspension with a TIG-welded chassis frame that is light and robust, easily sustaining a variety of loading conditions using a differential bar linkage. Our drivetrain motors are also velocity controlled, making driving over obstacles easier by automatically adjusting individual motor powers based on feedback. Our rover electronics are consolidated in a main enclosure integrated into the chassis frame.
By using custom PCBs that manage power distribution, controls, and communications of the ARM, drivetrain, and science modules, our electronics help keep the rover compact and lightweight. Our rover can operate and communicate up to 1 kilometer away from the main driver station, enabling us to perform all delivery tasks that may be presented. With a 5.8 GHz high bandwidth communication system, we can transmit multiple high-quality, low-latency video streams simultaneously that facilitate driving remotely. Drivers have clear vision of the task at hand and can identify, pick up, and deliver items to any target. With a website-based front-end, coordinates are input for navigation and drivers can monitor the rover's position and path during the entire mission. With our new compact driver station, we have an accessible long-range broadcast station which allows for quick and easy setup before missions. We are also developing a winged aircraft system to utilize as a repeater to facilitate out-of-line-of-sight roving. New monitoring systems for our drivetrain and drive station provide us with accurate and holistic data on the health of our rover's electronic systems. And as needed, our easy-to-access e-stop keeps roving safe for all members.
Our current 5 degree of freedom arm utilizes a closed-loop joint-by-joint control regime that provides easy driving to perform equipment servicing tasks, such as manipulating switches and buttons, servicing a lander, typing on a keyboard, and plugging in USB drives. Our user-friendly front-end provides multiple camera streams and an arm visualization, giving drivers full awareness of the arm's position at all times. Weekly thorough driver practices also continue elevating our competition readiness and act as systems tests to continuously check the state of the rover. We have also designed the arm and other sub-modules to be easily removable, allowing for quick configuration changes between missions. We are also developing an improved arm to further elevate our equipment servicing performance. With an additional degree of freedom, enhanced camera vision, reduced backlash, and a new custom electronic system, drivers can easily perform fine manipulation tasks with greater precision and course movements with more dexterity.
Our proven path planning and GPS system, with additional RTK correction, guides the rover during the autonomous mission to within a 3-meter radius of provided GPS points. To navigate to distant Aruko tags and objects, we use an efficient spiral search pattern equipped with accurate computer vision systems to detect both tags and objects in real time. During autonomous roving, our obstacle avoidance algorithm reroutes the rover around obstacles detected by a front-mounted stereo camera.
For the science mission, our science fingers are used to capture soil samples in situ that are deposited into our science module where a custom-built spectrometry system resides. Here, Raman spectroscopy and light detection facilitate life analysis on board the rover. With a luciferin-luciferase assay, fluorescence signifies presence of ATP and thus indicates an energy source for life. With the Bradford test, a color change signals the presence of proteins in the sample. A light sensor will detect both fluorescence and color changes. To create the panorama, the wrist camera and arm work together to capture multiple images, which are automatically stitched together and composited with cardinal directions and scaling. Our communication systems allows for the capture of high-resolution images for scientific analysis while tracking geographical data such as altitude and location. To attain at least 5 grams of subsurface soil of interest, we utilize off-the-shelf components integrated into a custom system that has been rigorously tested. Reversal of soil collection easily outputs only the soil of interest. Out of the hole drilled, we measure subsurface temperature and humidity with a handheld probe. Drilling, actuation, and data collection are all consolidated on a single custom PCB that minimizes the electrical footprint in the science configuration.
We have branched into outreach and mentorship efforts with a local science center and high school robotics students. We have also hosted inter-sub-team workshops to actively spread interdisciplinary knowledge to all Yonder Dynamics members, increasing our well-roundedness as a team. Thanks very much for watching. We hope to see you at URC 2024.